Hello, I'm listening. Hello. Is anybody there? I cannot hear you. Can you hear me? Hello?
Hi, can you hear me now?
Yes.
The process problem of being investigated.
Your sound is breaking. Maybe you could call me on the phone? Can you?
Yeah.
All right, what's my number?
What's the number?
611-6118. Hello? Hello? No. Something. Hello?
Hi.
All right, yeah, it's better.
Okay.
Okay. I don't know what microphone or what device you're using, but your sound is very low. Initially it was good, but now you should speak right in your microphone maybe. Yeah, now I can hear you, but when you start talking about the problem, I cannot hear you anymore.
Oh, okay. So I have a question about project problem 14.
There was a question about some angles. I'm not sure what. Okay. Oops, wrong. What is specific question?
Question 14 in the project. So it's like about.
Yeah, what is your question about that? Do you have it? So if you started doing a problem, right? You should have a picture, and in your picture you should have some elements of it, and you should have a specific question about something which unclear. So what is your specific question about what?
So I'm not understanding the child's motion. Like I think my drawing is incorrect of how he's moving on the swing.
Have you ever swung around on swings?
Yeah.
Yes, so that's what is happening. So the height of this person changes constantly up and down, up and down. Did you do problem 14 or 15?
No, I know there's similar ideas. I'm having trouble with both, and I think it's just the way of thinking about them.
So you have a picture, right? Can I see it? If it's on a computer, maybe you can share screen, or you can just show me. How do I do that?
It's not. I have it on like my notebook.
So what is gravitational? So it says calculate gravitational potential energy of the child relative to the child's lowest position. So when the child is at the lowest position, What is the angle between the swing and the vertical direction?
There is a lowest position would be 0.
0. This is what I want to do. So that's the lowest position. The trajectory changes. It moves back and forth, back and forth. This is the vertical axis. Right now, at the lowest location, there is no angle. All right. If it says calculate the energy relative to the lowest position. So right now, what is the height of a child relative to the lowest position?
Would this be the length of the chain?
So relative to the position, this position relative to which you're measuring everything has a name. We call it the origin. This is where we set the 0.
Mm-hmm.
So this position is set to 0 because you're told it has to be. So when the child is at the lowest position, what is the height of the child relative to that position?
0?
Is it above it?
No.
Is it below it?
No, it's like
No.
right on it.
So it's right on it. So this height relative to this position is 0. And I assume eventually this child swings up to the highest position. Here is the highest position. So this highest position, oh, then it swings back and forth, of course, but here at the highest position, what is the height of the child relative to the lowest position? That's the question you need to answer. And for that, you need the picture. And in your picture, you need to see that part of a segment, something you need to calculate. So how would you draw?
The lowest. Why would I draw the lowest position?
Would you draw the height of the child at the highest position relative to the lowest position?
I would draw a line between the highest and the lowest.
Like this?
Yeah.
Is this the height? How do we measure height?
The height is in the y direction,
So this is not the height. So how do you draw the height of the child at the highest position relative to the lowest position?
you draw like a line going down, a line like an L connecting those two dots to make a right triangle.
Okay. So first of all, the lowest position tells us the lowest level. 0 is not just here. 0 is everywhere on this level. So if you want to measure height, you want to measure it from this level. And would be this the height?
No.
No. So to draw the height, you would do perpendicular, the shortest distance, that's the height.
Right.
But of course, as you said, if you would use a triangle, this would have been the same height. Height and height at the height. So can you calculate this height? Because you will have to need it.
Yeah, they give you the angle.
Potential energy here will be mg0, but potential energy here would be gravitational potential energy, would be mgh.
Mm-hmm.
So you're right, you need to use trigonometry. Which angle do you know?
And we know the angle that the chains make in respect to the y-axis.
So you know this angle.
Yes.
Alpha. What else do you know?
We know the length of that red line we just drew.
So you know the length of the chain, because this length of this chain is also equal to the radius of the arc, a circle for this child. So now, this picture is not good anymore because it has too many elements. So you need to redraw the picture. This will be picture you need to use. L alpha H. So how do you solve it? How can you, what else? Can you do it right now?
I can try.
Well, what would be the strategy? There's something else I would add to this picture. Another length which we also know, but so far it's not in the picture. So far, this is just a copy of the picture from the left.
Mm-hmm.
But there's also another length in this picture which we know, which is so A, B, C, D. This picture has 4 points. So this length is equal to L. This is what we need to calculate. Do we know anything else? Because if we leave it like that, we can't calculate anything yet.
We know the weight of the child.
Well, the weight is a part of a calculation for the energy, but before that, we need to calculate that height. So if you can't calculate it, and tell me how you do it. If you can't, you need to either search for something or ask an additional question. So it's either or. Can you calculate this height right now? Can you see the screen, by the way?
I can, yeah.
Okay. If it gets fuzzy, you should tell me.
Actually, I guess we need to know the difference between A and B.
Between A and B, do you know it? No. Can you find it? Well, okay. If you need it, but you don't have it, try to find it. How would you find this distance? This is a good hypothesis, but now you have to make the next step. What would you do? How, if you say, I want to calculate this, what would you do? Or, okay, go ahead. Or you make a different suggestion, that's what it's, so what would you do?
I was gonna say try to find it, through using like data.
Yeah, of course, but you would have to write an equation. You want to call it theta, we can call it theta, it doesn't matter. If you look at this diagram, you should be able to write some equations because it's a right angle triangle. We learned everything about that. You may know a number for something or don't know a number, that is irrelevant. What you know is many, at least 4 equations you can write. So you can start from writing an equations. Can you write an equation? Any equation, write it down and tell me what you wrote. I want to write it here as well.
So, H is equal to AV times cosine theta. AT, sorry, like boy. Times cosine theta.
H is this from A to D.
Yes.
Well, AD and B, ADB triangle doesn't have any angles in it. I don't see any angles. I don't see theta. I don't see this angle. I don't see this angle. Do you know these angles?
So that, yeah, so I applied the theta from point C to A. Well,
So this is 90 minus theta, correct? But
yeah.
are you sure that CBA is 90 as well? Do you know the angle? CBA, this angle. CBA angle. Do you know its value?
No.
No, you don't. So if you don't know this value, how do you know this? You don't. You don't know that angle. That would have been easy. So this, first of all, this is maybe not theta. Secondly, do you know AB?
No.
No. So not really helpful equation. What does it mean? It means we have to move on and try something again. But again, this is a child on the swing. The child might move up and down, but the swing always keeps the same length for the chains. The length of the chain is the same, no matter where the child is.
Right.
So the length of the chain is the same when child is at the top or at the bottom or anything anywhere else.
Mm-hmm.
This is physical fact. Now you have to translate it into mathematical statement. If the length of the chain is the same, something else we should know about one of the distances in this picture. You don't have many. You have BC, BD, CD, DA, AD. I think that's it. BC, BD, BA, or BA. CD.
So then we have,
So one of these six, you have to eliminate all and say something about one. It's very specific. Go ahead.
I would say we know that BC or is equal to the length of the chain.
Okay. Where else?
And
You have to go and check each one by one and say something about each. Either we don't know, or we're looking for, or I know it. So what about CD? Do we know it?
CD would be L minus H or AD.
Why?
Because BA or AC is the length of the chain when they're at the origin or at rest.
So yeah, AC also is equal to the length of the chain. See? So this is what you're looking for. And it's related to the length of the chain and this shorter segment. So this is what you know. This is what you're looking for. If you only knew DC, your problem would have been solved. So now it means your question is, can I find distance from C to D? Can you?
Yeah,
From which triangle?
for the DCC.
So in this triangle, you know the hypotenuse, and you know this angle. In this triangle, how would you calculate CD or DC?
It would be L times cosine the theta they give you.
That's correct. So that's the final step of the reasoning. Now you just have to collect all that knowledge. If you know this, you can use it for the height, and then you can use it to the energy. That's it. This is exactly how it should be done. There's no other way. And as you can see, the physics part is not large,
No.
but visual part is important part of it, and plus some geometry. But the most important connection was between L distance for BC and distance for AC. As soon as you said that, everything came clear after that.
Yeah.
And that was physics. All right, you can finish calculation, it should work. So let's move on to another question if you have.
No, my question 15 is like a similar thing, so I think seeing this is going to be able to help me to do that too.
Well, you can try problem 15, it's very similar, I believe. Doesn't matter.
Yeah, it is.
Yeah, This one even has a picture.
Yeah, okay.
You just need to be careful about calculating. What do you need to calculate? It says calculate in problem 15, the change. And what is change by definition? How do we calculate change in anything?
Final minus initial.
Final minus initial, correct. That's it. So you will have to calculate final energy, initial energy. Well, you can see the initial and the final will be at the point B at the lowest location. And then you will have to repeat the strategy, the exactly same strategy.
Yeah, okay, thank you.
Sure. All right. We have this participants. All right, who's next?
Hi. I just have it's like kind of a simple question, but for some reason I
That's
can't
okay.
figure it out. So I'm trying to do one of the homework problems, and it involves like determining like clockwise versus counterclockwise of the, for like the forces, and I'm just struggling to like visualize,
Which particular problem? Maybe I can
It's
just.
part 3, number 7, and I initially like assigned clockwise and counterclockwise, and then I got it wrong, and so I tried doing it like reversing them, and I got it right. So I'm not sure like,
Is it part 3?
yeah.
Part 3, we skip this, we skip that, we skip this for the future. Which problem number?
7.
7. 7. Well, it's not just about clockwise and counterclockwise, it's about some algebra as well.
Yeah.
So the issue may have been with algebra, not with directions. So let's see if we can actually. Zoom messes it up. Zoom messes up all these functions. No, I can't. And they claim the best educational software. All right, so what are you looking for in the two forces applied diagonally? You have two different pictures. In each picture, the object is the same, the axis is the same, but forces are applied differently. And we need to calculate distances A and B. And we know that force number 2 is stronger than force number 1. So here what we have is 2 problems in 1.
Yeah.
So for first problem, forces are applied like this. But there is no motion, correct?
Yes.
Okay, that means we can apply the equilibrium condition. And for that, well, we got the picture, but for that you should choose the axis of rotation. Of course, I believe you did it here because that's the natural choice, right?
Yeah. And so I found like the lever arm for force 1 is B, and then for force 2 it's A, and then I
Correct.
used algebra to like determine that B was 4 times A.
Well, you said your question was about the direction of a torque. So torque number one,
Yeah.
relative to this axis, do you think it's positive or negative? It's not zero, because you just said that the lever arm for one is equal to B, which is correct. This is the line of action, the shortest distance, done. But what about direction, positive or negative? What do you think?
Well, I thought it was moving clockwise, but
That is correct, I don't know. So, I don't know, but there is a simple situation. You have an object that is kind of nailed in our mind here, and you pushing on this like this. So of course it's going to start moving clockwise, and that makes this torque negative. So you have to write this expression, and you're done with torque number one. What about torque number two? Is it positive or negative?
positive.
So that's for the torque number one. For torque number two, it would try to move it counterclockwise. That makes it positive. See, you have no issues with directions.
Okay.
And the lever arm would have been what? In this case, that would have been A.
A.
And if you add them up, oh, sorry, is it A or B? If you add them up, you should get what number?
0.
Because equilibrium, correct. And force number two is related to force number one. How in your problem?
Force 2 is 4 times force 1.
Okay. That means, yes, you can replace force number two with force number one, well, magnitude. 4 times F1 A equals 0. Force cancels, so 4 times A equals B. That's a condition we've got from the first picture, right?
Yeah.
All right, so now we just have to move on to the next picture. The next picture is the same object, the same axis, the same B and A, but forces now act differently. 2, 1. 2, 1. So you need to repeat the same reasoning. Torque number one, torque number two. So please, and I did it right. 1, so yes, did it right. So torque number one, positive or negative?
Negative.
So clockwise, negative, and how do you write the magnitude now? Force times, what's the lever arm?
A.
Now we know the problem. No, it's not. So the problem was not what you thought it was. You are good with directions. But the lever arm for this force is not A. How do you draw a lever arm? What do we have to do?
Oh, it's would it be 1 minus A?
Exactly. You have to draw a line of action. Then you have to draw perpendicular from the axis to the line of action and look at it. And that's
Okay.
1 minus A. So
Yes.
your lever arm is 1 minus A. And for
Okay.
2, of course, now it's going to be positive, and the lever arm is just B again.
Yeah.
So this is probably what the reason for mistake, because what you do is just add them up again. So negative F1 times 1 minus A plus F2 times B equals 0, and you can replace F2 1 minus A plus 4F1 B equals 0. And force cancels, and you get an equation for A and B. Second equation, and now you have 2 equations, you can solve them. Done.
Okay. Thank you.
Sure. So it's very easy if you just follow the, of definitions.
Yeah, I think I just missed that one part that the one minute said.
Well, you're not alone, trust me. Many people do exactly the same mistake in this problem.
Okay.
All right, next question, please.
I have one other question that's like
Go ahead.
on a different topic, but
Okay.
let me just find.
Is it about homework?
No, it's
Okay.
or I guess actually yeah, it did correspond to homework.
Okay, so I'm not
I think it was. Let me just pull it up.
homework.
It was part 2. Number 3.
Wooden block is at rest, and then a bullet hits it, and they together travel certain distance before they rest. Okay.
And I think I'm just like I was able to figure it out, but I'm just like not feeling super confident on like the process for how to solve a problem like this.
Okay. The thought process for this problem, first of all, is identical to the thought process we used for a ballistic pendulum situation. Remember?
Yeah.
So these problems physically are identical.
Okay.
And we have to start from the picture. So you've got the box at rest. We got the bullet flying. You may have different numbers. It doesn't matter right now. And that's what you're looking for. How fast was it traveling? That was the original idea of ballistic pendulum, to figure out how fast the bullet was traveling.
Okay.
What do we know? We know that they collided. So for the collision, we usually draw 2 pictures. One just before the collision, and second just after. So how would you draw the picture just after the collision?
Like with the bullet and the block.
Yeah, that's exactly how. There's the block. Bullet is stuck. And now they start moving together at solid velocity, block with the bullet. This is the picture just after the collision. So in reality, there is no space between these 2 pictures. It's the same. And then it keeps sliding, and eventually it stops. So the final velocity is 0, not 0. So how many problems do you see in this problem? Different physical problems.
3.
All right, we name the problems and we explain what is the first, second, third.
So like before the bullet hits the block, like right after it hits, and then once the block has stopped.
You were describing situations, not problems. Yes, you can see 3 different situations. The problem is related to a process. So we have only 2 processes here. One process we call collision.
Okay.
Second process we call, how do we call this phenomenon? When the box is sliding, how do we call it? Sliding. But for each process, we have to apply the appropriate set of laws or definitions. So if we talk about collision, what law, number 1, comes to our mind? What should we write? for every collision, the first thing we write, what is that?
That's
Every law has a name, and that name saves time for us when we need to search for that law.
law of linear momentum.
Law of conservation of linear momentum. So now we know what we need to search for. If we know the name, now we can find this law. And what does it say?
It says that linear momentum is conserved.
Of a system. This system has two elements before the bullet. So the linear momentum of a bullet before the collision plus the linear momentum of the box before they look identical. Of the bullet before the collision, of the object before the collision should be equal to the linear momentum of what? Well, in this case, the box with the bullet after the collision.
Okay.
Good thing this was 0, so all you have is mass of the bullet times velocity of the bullet plus 0 should be equal to mass of the bullet plus the mass of the box times that initial speed they have together right after the collision. Speed changes before and after, of course, not equal. So the first problem kind of, well, in general, is solved. But now the next problem begins, sliding. So for this problem, do we apply the law of conservation of linear momentum?
No.
No. So what do we have to apply in that case?
The law of conservation of mechanical energy.
Absolutely. We have 3 different forms for that. We could write law of conservation of mechanical energy, master equation, or work kinetic energy theorem. They're all physically, mathematically, ideologically identical. But I would say if friction is involved, use work kinetic energy theorem, less chance to make a mistake there. So now you make a choice. Okay, I want to choose work kinetic energy theorem. You need to know the name. Now you need to search for that. And what does it say? It says change in the kinetic energy is equal to the what?
The network.
Network. Exactly. So when this box is sliding somewhere here between the initial and final location, you need to draw a diagram. How many forces should you see in this diagram?
Well, the force of gravity and the normal force should be equal to each other, and they cancel.
My question was, how many forces? Your answer should be a number.
3.
3. And now we can say normal, gravity, and what is the third?
Friction.
Absolutely. Is there any force that pushes it to the right?
No.
No, but there's velocity still. It travels through. But how does acceleration point? I want to ask you.
To the left.
Absolutely, it slows down. So you see, you know everything. So now, network, well, it has to be equal to work done by gravity, that's 0, because it travels horizontally. You can ask a question if I speak too fast at any time.
Okay.
This is the displacement, delta S, so just S. And the force is perpendicular to displacement, no work. Normal force is perpendicular to displacement, no work. There's only one work done by friction. It actually will be negative because final kinetic energy is 0. Initial kinetic energy, what is the expression for kinetic energy?
1/2 mv².
Exactly. 1/2. What mass should I use here?
The mass of the block and the bullet.
Yes, it's total mass. Block and bullet times, and what variable, what speed should I use squared?
The velocity of the block of the bullet.
You don't sound confident.
Well, I'm just like, I guess it'd be the block and the bullet.
Well, technically, you should not be guessing. This process, sliding, begins here with the bullet already inside the box, right after the collision. The last instant of collision is the first instant of the sliding. So this is the initial velocity for this process, and that is why you have to use this velocity here.
Okay.
And this is the same velocity that was final for collision.
Okay.
And that has to be equal to the work done by friction. So now we're going to start thinking about work done by friction. And we know it has to be equal to -1 times the coefficient of friction times normal force times distance traveled. Distance traveled. Well, technically, that completes the reasoning. Because right now, all we have to do is just, well, no. You said it before, so it's a given that these two forces, normal and gravity, have the same magnitudes, and this mass should be equal to total mass of the system, the bullet in the box. So, can you see what should you do now?
Well, once you just like solve for the unknown.
Yeah, but in which order? What would be your first step now?
Well, you know what f of n equals. So you can plug that in and find the work done by friction.
Exactly. So you would start from this equation, because you can replace normal force with mg. That's the first step. And that actually eventually will give you this speed you're looking for. Because you need to use this speed, this expression, to finally calculate this speed. So your work now begins backwards. Your theory started from left to right, but your calculations will go from right to left. Any questions?
I don't think so. I think I just need to like solve it out.
Yeah, you know,
like,
distance, this is L. You know coefficient, this is this. You know G, 9.8. And in the last equation, math doesn't really matter, although you know. So you plug the numbers, you calculate VBB, and then you use VBB to calculate VB. That's it.
Okay, that makes sense. It's helpful to break it down into the collision and the sliding.
Well, you cannot put two different processes in one because there is no law for that situation. We only have a law for collision, and we only have a law for sliding.
Okay.
That means we have to break the situation apart into individual parts, individual processes, to be able to apply the laws we know. That's the only way to do it.
Okay.
All right. More questions?
I think that's it for now.
All right. So is there anybody else here? No. Around someone just joined. Okay.
Thank
Hello?
you.
Oh, sure.
Hi,
Hello. Go ahead.
we were just talking about question 14.
Yes, I remember.
So I did question 17.
Just give me a second.
I mean 15, sorry, yeah. And
13.
I'm not, I think I'm doing like, something must be wrong with my sign, because I calculated the correct gravitational potential energy. So when I put in my positive value,
Which part, A, B, C, or D, you're referring to?
it's question 15 on the practice problem. There's only one.
15? Oh, 15, I saw.
Yeah.
Well, you have to calculate the change. The change has to be equal to final value minus initial value. And the final position is lower than the initial.
Right.
So you need to calculate two numbers and then subtract one number from another number.
Right, and I got a positive value.
Well, you did something wrong.
Right, and that's why I'm not sure. Like I do, my value itself was correct, but it just wasn't negative. So I think I'm missing a negative in one of my equations.
No. The equation for gravitational potential energy doesn't have any sign in it. The equation for the gravitational potential energy says this is what you do, mg, right?
Mm-hmm.
So you have to use three numbers, two the same numbers. The third number depends on the location.
Right.
So tell me, what is your number, y coordinate for the initial location?
Okay, for the initial location, I got 1.27.
Okay, 1.27. What is y for the final location?
1.5.
That cannot be right. If you look at the picture, you start from here, that's initial, you end up here, that's the final. You don't fly up, you go down. So I don't know what you did, but your final number should be lower than your initial number. If you could share a picture or your work with me, I could try to find out what went wrong. But at this point, I only can point at the fact that this doesn't make sense. Your final position should be lower than initial.
Okay. Yeah, I can't share, sorry. It's on paper, that's why.
Well, if it's on the paper, maybe you could use a camera, or you don't have camera.
No, sorry.
Well, you could technically take a picture and email it to me as well. That would take more time. Or even better, that's what you should do. Please do that. Take a picture and post it on Piazza and say practice problem 15. This is my picture. This is my work. You don't have to use your name. In that case, eventually, me or someone else will address it. That's it.
Okay, I'm good.
All right. Thank you. So, next question, please.
Hi, I have a question about the homework part 3.
Homework.
Question 7. So, the strategy I'm using for this problem is I'm trying, since they tell us that the net force is 0.
Is this a problem with let me see,
I can share the screen with you if you need.
just a second, because I may have talked about it already. Is this problem like this?
Yeah.
All right. So, because I already had a conversation about this problem, you just have different numbers. Let me first just ask, where did you choose the axis? Normally people would choose it.
I chose it right there, yeah.
Okay. In that case, in each situation, one torque will be positive, one torque will be negative.
Yeah.
So that's the next thing to check. Do you have negative positive, and do you have negative positive, or you have something different?
Yeah.
Okay. So next, the sum is equal to 0, but forces are related. Your coefficient might be different. What is your coefficient?
5.
5. Well, so your equation will have a different number in it, but still, the strategy is the same. So you will have 5A equals B, right?
Yeah.
Now, when you move on to the next picture, what is your lever arm for the torque number 1?
I did 1 minus A.
That should be right. So if this is your torque number 1, and this is your torque number 2, that should be your second equation with a 5, and you have to solve 2 equations.
Yeah. Maybe I'm messing up the math part.
Probably something with mathematics, because everything up to this point, what you said was correct.
We would set the 2 equations to equal to each other, right? And solve for.
Well, that's mathematics. That means there are many different approaches to solve mathematical equations. What do we do? What do we do? Ah. Okay. So, I forgot. 4, or let's say 5. 5A equals B. And what is it? Negative 1 minus A plus B equals 0. Oh, 5B, 5B. Do I have equations the same as you do?
Yeah.
All right. So what do you suggest to do?
Plug in B as 5A.
All right. So that's probably the best way we can replace. So let me check on the phone. 2. So if we replace B with 5A, we get this.
Mm-hmm.
So what's next?
Multiply it out. I got 26A is equal to 1.
Where did you get 26 from?
I multiplied out the negative sign, says minus 1 plus A plus 25A is equal to 0.
Okay, so times everything rounding negative 1. 1 minus A minus 25A
Isn't it plus A? 1 plus A?
plus A. Exactly, that's why it's not 26.
Oh, right.
Exactly, that's why it's not 26. So that's gonna be 1 equals 24A.
Isn't, why is the 25 negative?
Well, you said you're multiplying everything by -1, so that's what they did.
Oh, I meant to say, just on the parentheses.
That's, I don't understand. You cannot just erase a minus and replace it with a plus. There is no in mathematics function like that.
No,
Erasing
that,
is not operation.
I meant,
Operation, well, I don't know. You have to apply the correct operation. And the
Yeah.
correct operation is you can multiply this equation by any number, or you can divide it by any number, or you can add this equation any number, or you can subtract any number.
couldn't I multiply out the negative, the parentheses, distribute the negative sign among 1 and minus a? You get -1 plus a plus 5 times 5a.
You're right. In that case, that would have been negative.
So it would be 26a is equal to 1, right?
1 plus a plus 26a.
Or 25a.
25a.
Yeah.
That is correct. So 1 equals 26a.
Okay.
Did it work for you?
Let's check, see if the answer is correct. I think
So
did I try to substitute it in a really complicated way?
and so I'm just checking. That's exactly.
Good off screen.
F2
Yeah.
is
Or try to substitute it to like complicatedly.
and F1b. B is equal to 4a. And here we substitute for F2 for F1. F1 is B related. Yeah. I made a mistake, you made a mistake, we fixed it. And what mistake did I make? If I multiply by -1, I've got 1 minus a minus 25a equals 0. So 1 equals 26a. Yeah, of course, it doesn't matter how we do it. A should be equal to 1 over 26. The question is asking for
A and B.
for A and B in meters. Now, sometimes you just have to pay attention to the unit because you may calculate meters, but Weber sign tells you enter centimeters. That happens a lot. So
I think, yeah, the problem with me was that instead of solving for like a simpler way, I think I tried to go at it too complexly and made like a mathematical error.
maybe, yeah, but it's fixed now.
Yeah. Thank you.
Sure. And I guess we are done. All right.